Hi gentlemen, these will be your notes for Unit 0, Day 8 from Calculus. If you would like to see the warm-up or review problem or any of the homework questions we covered, just look at the finished notes from today. So today we're going to talk about inequalities, how to solve linear inequalities, how to solve polynomial inequalities, and rational inequalities. So solving inequalities, linear inequalities. So if you remember, we can just distribute and then subtract the 8 over. And then remember, when you divide inequalities and you're dividing by a negative number or multiplying both sides by a negative number, the inequality sign flips. So this would be x is greater than -2, or in interval notation, you would go from -2 to infinity. Or if we had to graph it on a number line, it would be a closed circle on -2, and then it would shade to the right. Absolute value inequalities, you need to get the absolute value by itself, so we can add 6 to both sides. And so 3 times the absolute value of 2x minus 1 is greater than 18. And then we still need the absolute value by itself, so we would divide both sides by 3. So the absolute value of 2x minus 1 is greater than 6. And so that means that this number's distance from 0 is greater than 6. So to be away from 6 away from 0, you're either here or here, and you want it to be greater than 6. So you want it to go this way or this way. So this is going to be an or problem. So either 2x minus 1 is greater than 6, or 2x minus 1 is going to be less than -6. So just looking at that picture, right, the 2x minus 1 needs to be bigger than 6. That would represent this picture, or it needs to be less than -6. That would represent this picture. And now you would just solve both of these. So add 1, 2x is greater than 7, or x is greater than 3.5, or add 1, 2x is less than -5, so x would be less than -2.5. And those would be your two solutions. Solving polynomial inequalities. So these are ones where you can think about them a couple different ways. So the first thing is we want to know when this parabola is less than 0. So if this is a picture of the parabola, and it's not the exact picture, but we would want to know where this is less than 0. Well, it's less than 0 where its y values are negative, so underneath that bottom part of the parabola. So what we're going to try and figure out first is where would it be exactly 0, because those are going to cut off where the parabola is positive and where it's negative. So I'm going to factor and solve this. So x, and what multiplies to -48 and adds to -2, that would be -8 and +6. So x equals 8 and x equals -6 are going to be my intercepts. So this could be -8 or -6 and +8. So what I typically do for these problems is I make a sign chart if I don't know what the graph looks like. So, and you can think of it as a number line. So -6 would come first on the number line. 8 would come second on the number line. And I know both of those places my parabola is at 0. I'm going to test what happens on the left-hand side of -6, so I could test like -10. I'm going to test what happens in between -6 and 8, so I could test like a 0.0. And then I'm going to test what happens on the right side of 8, so I could test +10. And all I'm going to do is I'm going to plug these back into the factored form. So if I did x minus 8 times x plus 6, and I plugged in -10, so -10 minus 8 and -10 plus 6. Does it give me a positive answer or a negative answer? Well, this would be a negative, and a negative times a negative is positive. So any answers to the left of -6 should be positive. And then again, looking at my graph over here, yeah, all of those answers are positive y values, so that makes sense. Now if I plug in 0, so again, we'll plug it into the factored form, x minus 8, x plus 6. If I plug in 0, 0 minus 8, 0 plus 6, I would get a negative answer and a positive answer, and a negative times a positive is negative. So any answers in between -6 and 8 on that parabola should generate negative values. And look, it did, so we're good so far. And then I'm going to test 10. So again, plug it into the factored form, x minus 8, x plus 6. And if I plug in 10, 10 minus 8 times 10 plus 6, I would get a positive answer and a positive answer. So that would generate positive values for my parabola. And then if I look, you're right. Every answer to the right of 8 would be positive answers on the parabola. All the y values would be positive. So again, you look back at the original problem. If I want it to be less than 0, I want where it would have negative answers. Well, I have negative answers here between -6 and 8. So my solution would be -6 to 8. or x is between -6 and 8. The next one is a little bit harder because it's not just a parabola. So typically on these, I'm going to just use the number line, the sign chart, to test what happens. So I'm going to try factoring by grouping because I need to know where it's exactly 0. I'm going to pull out the 3x squared, and then I would get x minus 2, and I'm going to pull out the -2, and I would get x minus 2, and then I want to know where this is greater than or equal to 0. Through 3x squared minus 2 times x minus 2 is greater than or equal to 0. So either x is plus or minus the square root of 2/3, or x is 2. So the smallest value is going to be negative square root of 2/3. And then I'm going to use 0 as a test point, and then the positive square root of 2/3. And then I'm going to use 1, and I'm going to use 4, and I'm going to use -4. So I know that it's exactly 0 at negative square root 2/3, positive square root 2/3, and at 2. So those are all zeros, and then these are my test points. So I want to test something on the left of negative 2/3, in between negative 2/3 and positive 2/3, in between the square root of 2/3 and 2, and then after 2. So I need to do test points for all of those to see whether my function generates positive or negative values. So again, I'm going to plug into the factored form. So 3x squared minus 2 times x minus 2. What happens if I plug in -4 into both of those parentheses? Well, I would get a positive answer, and I would get a negative answer. So this would generate negative answers. If I plug in 0 into both of these, I would get a negative and a negative. So this would generate positive answers. If I plug in 1 into both of those parentheses, I would get a positive answer and a negative answer. So this would generate negative answers. And if I plug in 4 into both of those parentheses, I'd get a positive and a positive, and a positive times a positive is positive. So those would be what would happen on the graph. I want to know when this polynomial is greater than or equal to 0, so I want to know where it's positive. So where in this table is it positive? Well, it's positive in between negative square root 2/3 and positive square root 2/3, or negative square root 2/3 is less than or equal to x, which is less than or equal to positive the square root of 2/3. And it's also positive over here, and that is when I'm greater than 2. So from 2 to infinity, it's also positive, or x is greater than or equal to 2. So those would be my solutions. Solving inequalities, so rational inequalities. So rational inequalities, again, we need to make a sign chart, but in order to do this, for these, you do the numerator equal to 0, and the denominator equal to 0, and those are the numbers that are going to go in the sign chart. So for the first one, x minus 5 equals 0, x plus 3 cannot equal 0. So the two numbers that I'm going to use in my sign chart are going to be 5 and -3. So here's -3, here's 5. At 5, it's 0. At 3, it doesn't exist, so I'm just going to put a 0 through it with a bar through it. And then I'm going to test on the different sides. So on the left of -3, I could test -10. In between -3 and 5, I could test 0, and bigger than 5, I could test 10. So I'm going to plug that into the original x minus 5 over x plus 3 because it didn't factor. So if I plug in -10, I would get a negative over a negative, which is a positive. If I plug in 0, I would get a negative over a positive, which is a negative. And if I plugged in 10, I'd get a positive over a positive, which is positive. And here I want where it's less than or equal to 0. So I want my negative solutions, and negative solutions are in between. So it's going to be in between -3 and +5. Since my function couldn't equal -3, I've got a parentheses, and then since it can equal 5 and it can equal 0, I have a hard bracket there. So -3 is less than x, which is less than or equal to 5, and that would be my solution there. So you can write it in inequality notation or interval notation. So you guys go ahead and try that one, and you guys can check it against the finished notes to see how you did. And those are solving inequalities. We're also going to talk about how to solve systems of equations today. So if you wanted to solve a system of equations graphically, you're just going to graph them and see where they intersect. So that first one, 2x minus 3y equals -6, I'm just going to graph with intercepts. So if x is 0 on that first one, then y would be 2. And if y is 0 on that first one, then x would be -3. So I have the point 0 for x, 2 for y, and -3 for x, 0 for y. So here's my first line. And then my second line is just going to start at 2, and then it's going to go down 1 over 1. And so my solution is where those 2 points intersect, and they intersect right here. So my solution to that system graphically is going to be the point 0, 2. On the next one, we have a circle and a parabola. So the first one's a circle, and the center is 0, 0, and then the radius is 3, so I'm going to go up 3, out 3, down 3, and over 3. So here's my circle with a radius of 3. And then the next one is a happy parabola that moved 2 down. So here's my happy parabola, it moved 2 down. And I'm just going to sketch it in. And so my solutions are the 2 points where it intersects. And so graphically, without using Desmos or a graphing calculator, you would just estimate those points. But I would let you guys use Desmos, which we're going to do next class. So solving linear systems algebraically. So if I wanted to solve that first system that we just did, and we wanted to solve it algebraically instead of graphically, you've got a couple options. You can use substitution or elimination. Since y is already solved for in that second equation, I can take the y and plug it into the first one. So I have 2x minus 3 times y, which is negative x plus 2, is equal to negative 6. And then distribute 2x plus 3x minus 6 equals negative 6. So 5x minus 6 equals negative 6. So 5x is equal to 0, so x would be 0. And then we know y equals negative x plus 2, so plug in the value we just found, so y would be 2. So where they intersect is the point 0, 2. And that's exactly what we got up here. Solving nonlinear systems algebraically, again, you have the same options. You can use substitution or elimination. So for here, since y is equal to x squared minus 2, we could take that and plug it in for the y. So I'm going to take x squared minus 2 and plug it in for this y. So now I have x squared plus y squared. So that's x squared minus 2 squared equals 9. So this is going to be x squared plus x squared minus 2 times x squared minus 2 equals 9. So this will be x squared plus x to the 4th minus 4x squared plus 4 equals 9. Get everybody to the same side. So x to the 4th minus 3x squared minus 5 equals 0. And notice it's not pretty. And so we could use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so this is going to be x squared because the middle term is x squared. So x squared is going to equal 3 plus or minus the square root of 29 over 2. And then you would just take the square root of that once you're done, get your decimal answers, and go. So you guys can check your work. I'm sure we graphed this on Desmos and found those decimal points. And then I'm sure we used the quadratic formula and worked this all the way out in class. So you can check that work against your finish notes. Let me know if